next concept in some basic concepts of chemistry is stoichiometry. So first we want to know what is meant by stoichiometry. It deals with the stoichiometry is a branch of science which deals with the calculation of masses and volumes of the reactants and products involved in a chemical reaction. If you take a chemical reaction, that chemical reaction involves reactants and products. Whatever the masses, calculations of masses of volumes of reactants and products involved in a chemical reaction, that has to be taken as or explained by this stoichiometry. Okay, in that now we want to know one more important topic, that is what is limiting reagent. So it is defined as the reactant. It is related to completely reactant involved in a chemical reaction which is completely consumed during a reaction. In a reaction, if any reactant is completely consumed, in a reaction if any reactant is completely consumed, then that is called limiting reagent. Next, what is excess reagent? The reactant that is not completely consumed in the reaction, the reactant which is not completely consumed in the reaction, that is called excess. That means a little amount of reactant is left even after completion of reaction, then that is called excess reagent. Excess reagent is not completely consumed. Limiting reagent is completely consumed. Okay, now we want to see the problems related to this limiting reagent and excess reagent. Here is a problem that N2 and H2, two elements, two compounds, N2 and H2, two gases are react with each other to produce ammonia. They are producing ammonia according to the equation. N2 gas and H2 gas react together and can give ammonia gas. What we want to do, calculate the mass of ammonia. ಓಕೆ, ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಅಮೋನಿಯಾ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರೋದು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ವಿ ವಾಂಟ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಮಾಸ್ ಆಫ್ ಅಮೋನಿಯಾ ಪ್ರೊಡ್ಯೂಸ್ಡ್ if 2.0 into 10 to the power of 3 grams of N2 reacts with 1.0 into 10 to the power of 3 grams of H2. When this much amount of N2 and H2 is reacted, then what is the amount of ammonia gas is liberated, that we want to find out. So that is our question. So first we'll see reaction. What is the reaction? Our equation given, N2 plus 3H2 is gives rise to 2NH3. All are in gaseous state. Okay, first write down its atomic masses. Atomic mass of each nitrogen is 14. 14 into 2, 28. Each hydrogen atomic mass is 1. Totally 3 are there. 3 into 2. 2 hydrogens. Each hydrogen is 1. 2 hydrogens 2. Then here, what is ammonia atomic molecular mass? 17. For 1 ammonia 17, 2 ammonias 2 into 17. Okay, now 28 grams of N2 reacts with 3 into 2 grams of H2. First write down this. 28 grams of N2 reacts with 3 into 2 grams of H2. Then this much amount of nitrogen can react with how much amount of H2? Because first we want to know what is limiting reagent, what is excess reagent. So 2 into 10 cube grams of N2 reacts with x grams of H2. We want to find out this. You just cross multiply this. Then x is x grams of H2 is equals to, we are cross multiplying, 3 into 2 into 2 into 10 cube divided by, when these two are multiplied, this comes as a numerator, so denominator 28. By calculating all this, you will get 428.57 grams. Okay, this is H2. This is the H2. For reacting this much amount of N2, we require this much amount of H2. Okay, clear? Then amount of H2 unreacted, it is in 1 kg. So 1000 minus 428.57, you will get here 571.428. That means this much amount of H2 is not reacted. That means it is not completely consumed. If it is not completely consumed, that has to be considered as excess reagent. If it is completely consumed, the that is the limiting reagent. Now N2 is completely consumed, so it is the limiting reagent. N2 is limiting reagent. Now N2 is used to find out the mass of ammonia gas. Now first, 28 grams of N2 can give 2 into 17 grams of ammonia. 28 grams of N2 can give 2 into 17 grams of NH3. Then this much of nitrogen can give how many moles of ammonia? 2 into 10 cube of nitrogen can give x grams of NH3. Then x we want to find out. Andre, now we want to cross multiply these two and this. Then x equals to 2 into 17 into 2 into 10 cube divided by 28. By calculating all this, you will get 2428.57 grams of NH3. This is about the X value, which is nothing but mass of ammonia gas is obtained when this much amount of N2 react with this much amount of H2. That means mass of a product is always find out if you know limiting reagent. Limiting reagent is a reagent which is completely consumed in a reaction. Okay, if any reactant is not completely consumed, that is taken as excessive reagent. Now here is one more question. How many moles of methane is required to produce 22 grams of CO2 after combustion? That means here CH4 is undergoing combustion. First write out CH4, methane is a gas undergoing combustion, that is burning in presence of oxygen. Carbon oxidized to convert to carbon dioxide. Hydrogen combusts to give water. To balance the reaction, take here 2 moles of oxygen. 2 moles of H2O. Molecular formula of CH4 is 16 grams. Molecular formula of CO2 is 44 grams. Here nothing is there, means 1 mole. Even here 1 mole. Okay. Then 1 mole, 44 grams of CO2 is obtained. 44 grams of CO2 is obtained from 16 grams. That means 1 mole of CH4 can give 44 grams of CO2. We can also write in this manner. This is 16 grams, this is 44 grams. 1 mole of CH4 can give 44 grams of CO2. Then X moles of CH4 can give 22 grams of CO2. 22 grams of CO2. So in that 22 grams of CO2, what is the required amount of CH4 we want to find out? For 22 grams, what is required amount of CH4 that we want to find out? See, I am writing here 1 mole of CO2 can produce, CH4 can produce 44 grams of CO2. Then to produce 22 grams of CO2, what is the mole of CH4 is required? That is X moles of CH4 we will write. Okay, we want to find out X. We just cross multiply it. Okay, then X equals to 1 into 22 divided by 44. We will get 0.5 moles of CO2. That means to obtain 22 grams of CO2, 0.5 moles of CH4 is required. 0.5 moles of CH4 is required to produce 22 grams of CO2. Like this we will find out even the required amount of oxygen or any other element for the combustion and some other reactions. And this is another question related to the same matter, that is homework for you. You just try to find out the answer for this. Now the next concept is mass percentage. Mass percentage is defined as the mass of the solute present in 100 grams of the solution. So a solution is nothing but a mixture of solute plus solvent. Solute plus solvent. This is called solution. Okay. The total amount of solute, the solute present in 100 grams of solvent, 100 grams of solution. is called mass percentage. That mass percentage is always equals to mass of the solute. We have taken a solute divided by mass of solution. Mass of solution is nothing but mass of solute plus mass of solvent into 100. So by using this formula you will get mass percentage. Here is a problem related to that. A solution is prepared by adding 2 grams of substance A and 18 grams of water. Calculate mass percentage of the solute. Here A substance is dissolved in 18 grams of water. Water is a solvent. A is a solute. Water is a solvent. A is a solute. What is the amount of A is added? 2 grams of A is added to 18 grams of water. Then the total mass of solution is 18 plus 2. What is mass of solute? 2. Mass of solvent 18. Mass of solution 2 plus 18. Then mass percentage is equals to mass of solute. What is mass of solute? 2 divided by mass of solution, that is 2 plus 18 into 100. You will get here 10%. That is about the mass percentage. Simply we can find. Next, another one is molarity. So molarity is defined as the number of moles of solute present in 1 liter of solution. 1 liter we can also write in the form of 1000 cubic centimeters. So it is defined as the number of moles of solute present in 1 liter of the solution. Then molarity is always equals to WB by MB into 1000 cubic centimeter divided by volume. WB is nothing but weight of the solute. MB is nothing but molar. WB is weight of solute or mass of solute. MB is molar mass of solute. V is the volume of the solution. Here is a problem related to that. Calculate the molarity of sucrose. Sucrose is B, solute, in mole per liter when 10 grams of sucrose, this is WB, weight of the or mass of the solute, is dissolved in enough water to make 500 ml of solution. This is V. This is what? WB. And MB we can calculate by using this formula. Then molarity of a solution is equals to WB by MB into 1000 divided by volume. What is MB? 10 divided by WB is 10. MB is, by calculating this you will get, just add the sum of the atomic masses of elements present here. By adding all this you will get 342 into 1000 divided by volume of the solution V. That V value is 500. By calculating all this you will get 0.0584 molarity. That is about the molarity of a given volume of solution. So in the same manner we can also give one more term, that is molality. It is defined as the number of moles of solute present in 1 kg of solution. 1 kg of solution, that is called molality. Molality, in place of liter we will take 1 kg. That's it. In place of 1 liter, if you take 1 kg, you will get molality. Molality is here L and it is indicated by small m. Molality is defined as the number of moles of solute dissolved in 1 kg of solution. Here we have taken 1 liter of solution for molarity, 1 liter of solution for molarity, 1 kg of solution for molality. Okay, so by using that we can easily find out about the molality of a solution. So this is about the important concepts related to some basic concepts of chemistry. That is about the chapter. So with this, some basic concepts of chemistry chapter is completed. Understand? And whatever the questions I have given for homework, you just try to do that and send answers to me. Thank you.